So today I'm going to be covering an enhancement concept of list and dictionary, okay, which is so far covered. And yesterday I hope some of the examples covered, and tomorrow also we'll cover some more examples, okay. But today I will cover a simple topic called list comprehension and dictionary comprehension on top of the traditional list and dictionary, what it mean and how we are using. And also I will cover nested loops, like how we will execute loop within the loop based on the requirement. We'll see that also, okay. And also if time permits, some build functions also we'll see, okay. So first thing, uh, maybe I will open a simple notepad, okay. Yes. Yeah, so first one, list comprehension, okay. So basically list comprehension means or dictionary comprehension means, if you want to write a logic, or if you want to filter the data, or if you want to apply the logic on the existing list or dictionary to create another list or dictionary, generally we can use this comprehension instead of, okay, traditional loop logic, okay. Why? Because if you are using the traditional logic, it takes a few more lines of code, and also we need to write multiple lines of code. So instead of that, we can use simple list or dictionary comprehension in the single line. So instead of writing multiple lines, we can use the single line, okay. So that is the basic advantage. And even when you go for nesting loops also, instead of writing the multiple loops, we can also write single line entire logic. So that is the basic advantage of the when we go for list comprehension or dictionary comprehension. So in simpler words, if you speak about, if you want to generate a new list from the existing list or existing logic in a single line without using the traditional for loop logic, we can use the list comprehension. Similar way, if you want to apply the same way of implementation on the dictionary, we can use the dictionary comprehension, okay. So I will show you a few examples, so it might help you to understand easily, okay. So I will take the one case study for you to understand, okay. So let's take example. Okay, let's take example. There is a list with let's take some values are there. Assume that 1, 2, 3, 4, 5, 6. Assume that, okay. Now I want to filter out only even numbers from this list. Assume that, okay. I want to filter only even numbers, okay. In this case, simple traditional, if you want to write a simple logic, let's take even underscore li. Will take a empty list initially, and for x in li. That means for every element in the list, I'm checking whether x is even number or not. So as we know the traditional logic. So if x percentile equal to 0, then I'm writing even list dot append followed by x. So now if you print the even number list, okay. So now as we know, this will give the only even numbers from the actual list. See, if you see the 2, 4, 6. First of all, does anyone doesn't understand this logic? First of all, it is a traditional logic. We are iterating each value in the list, and we are checking that whether that value is even number or not. If it is even, I'm storing into another list, and that list I'm printing. So this logic is clear for everyone or not? First, let me clear with that, so that I will go with the comprehension logic for the same. Did you people understand this logic?
Yes, sir.
Perfect. Now, see, same. Now, if you see here, we took almost 4 lines of code in this logic, like line number 2 to line number 5. So these 4 lines of code we written to get the even number list from the existing li. First point. Second point, we used separately another list called even li, and again we need to allocate the memory from this even list also, right? So these are the 2 drawbacks I can say. That one is extra list we used for storing that even numbers, and second thing, we written 4 lines of code to achieve the logic, achieve the goal, okay. Now I will write the same logic in a single line, okay. So same li I'm taking now. Okay, let's take li1 I'm taking. Now see, same li1, I want only even numbers, right? So simply square bracket. See here, x. Now this is the value what I want, that is even number or not, right? So for that, first we need to iterate. So for x in li. So simple. This line is complete. See, I'm writing everything in single line. This line is completed. Now what should I write? The condition. So for x in li, if x percentile 2 equal to 0. You see that this is completed. Now this even list dot append x will take care of this x. You don't require to write again append. Okay. Now we are printing the L1. Simple. If I print the Li1, okay. Now you will also get the same output. You see that here. See that 246. Now 4 lines of code with extra list without using any of that. I written entirely in single line. If you see that. So this is what we call list comprehension. So that means comprehension means short compress the code into single line. So that is what we are achieving in the list comprehension. See, this is the simple syntax for the list comprehension code. So that means we generated a new list from the existing list by writing in a single line. Okay. So this way of writing only we call list comprehension. Okay. So if you clearly observe that, so here first we are writing the for loop and then we are writing the if condition. Okay. So any doubt as of now? Any doubt till this point? Yeah. So now this list comprehension we can write in different syntaxes. I'm telling, just if you want to write a simple syntax, well, I can write v for v in collection. This is the straightforward simple syntax. Okay, collection means here you can write any object or even range also you can write here. Instead of array, you can write the range also. Okay. And now, if you want to apply the only if condition, just before I written v for v in collection, syntax as I'm telling. Okay. If condition, you should write condition over here. So that means if this condition successful, then only this value will be stored. Otherwise, it won't be stored. If you want to apply the if else, both conditions at a time. Okay. So then we should write value. Okay. If condition. So if condition came first and else another value or expression also, whatever it is, another value for value in collection. So this is if else notation. Okay. So likewise, if else also you can use in the single comprehension. So mostly we use these three combinations of what you can say that syntax. So I will show you the third one also now. Let's assume that in the same example, instead of filtering the even numbers, what I want to do, if it is even, I want to print even as a text. If it is odd, I want to print as a odd text. So now we can use the third this syntax. Okay, let's comment this. Now you see li2 is equal to, let's take 1 comma 2 comma, or otherwise instead of this I can use the range now to make you to understand that also. Li2 is equal to, see, first what I want to print if condition, first I want to print even for even, right? Even if x percentile 2 equal to 0. Else what I want to print odd. You can print the expression odd for x in range of, let's take 1 comma 11. So 1 to 10 or 1 to 6 till the 5 it will get. Now print li2. See that. So now if I run, you will get the as a text. See that for each value, whether 1 is odd, 2 even, 3 odd, 4 even, 5 odd. Likewise, the if else also you can use. So this is the syntax for list comprehension. That means with the single line of code, you can filter the data, you can reduce the data. I mean to say you can find the sum or average of the data, and If you want to do any operation, you can also do the operation also. It based on your request. So any doubt, please let me know. Otherwise, we'll go with dictionary comprehension. Any doubt?
No, sir.
Okay, perfect. Then we can go with dictionary comprehension. Okay. Same as you know, right? Dictionary means we have to write the for loop to iterate the either keys or values to operate on that. Okay. And if you want to manipulate the keys or manipulate the values, we can use same if condition, like for condition, like for value in dictionary dot keys or dictionary dot values or dictionary dot items, like that we have to use, right, for loop. And after that, again, we have to write conditional if condition. But instead of that, again, if you want to write any single line operations on the existing dictionary, yes, again, we can use the dictionary comprehension. Okay. So what is the basic syntax for this? So curly bracket, dictionary notation is curly bracket. So we have to write the curly bracket and then expression or value. Okay, expression or value we can use colon, because key followed by value, right? First one expression and then value expression. So this is key expression. I can say that key expression. Okay, key colon value. Now these two, how you want to iterate, you can iterate. Like for let's take item in collection. This is the way how you want to create the dictionary based on the existing collection. Okay. So now what I'm trying to do, simple example I will explain. Let's take Li is equal to, we have 1, comma 2, comma 3, comma 4. Okay. Now what I want to do, for each value, I want to map square of that as a value. Let's take example, 1 is a key, 1 square is a value. 2 is a key, 2 square as a value. 3 is a key, 3 square as a value. Like that means 1 colon 1, 2 colon 4, 3 colon 9, like that. Key value I want to generate based on the existing collection. So now I'm writing D is equal to, now you can understand easily. See, first we want key. What is the key? Let's take, I'm writing K colon. What is the value here? I want to value square of it, right? So simply you can write K star K. For from where you want to get this K value? From the Li. So for K, sorry, for K in Li. So now you can print D, you will see the output. Now instead of writing the for loop, I write in the single dictionary. Sorry. Now you see 1 colon 1, 2 colon 4, 3 colon 9. Like that, we got the dictionary. So both list comprehension and dictionary comprehension will help you to generate the respective collection, like it may be list or dictionary, using a single line of logic instead of multiple lines. And here also we can use the if else or if condition also. Like example in this also, if you want to get only even numbers collection only, you don't require odd numbers. So then also we can use same previously how we use, like example K colon K star K for K in Li if K percentile, sorry, for K percentile to equal 0. Now the D1 will contain only even numbers along with it squares. D1. Okay. Now run it. See that 2, 4, 4, 16. There is no 1, 3, 5 now. Likewise, you can write the if, and similarly, as like previous one, you can also write the else case also. Okay. So this is what we can use the comprehension logic in both list and dictionary. So any doubt as of now? So this is technically called as list comprehension and dictionary comprehension. So it's not a big topic, but sometimes it might help you to reduce the number of lines to write in a single line. That is what the major advantage of list comprehension or dictionary comprehension. But technically, even we can achieve the same logic by using your traditional for loop and if condition combinations. Any doubt till this point?
No,
Okay, great. So now we will go with another simple topic called nested loops. Okay. So basically, whenever you want to write a loop within the loop, it may be for within the for or while within the while. If you want to write a loop within the loop, generally we use general nested loops. Okay. So, but in real time, most of the times, if possible, we can eliminate the nested loops because it takes huge time to execute the logic. So let's take, if you have the 5 iterations, so if you want to run the nested loop for the 5 iterations, it takes 25 times because outer loop will take 5 times and each outer loop inside loop also will take the 5 times, right? So 5 into 5, 25 times. That is what we call big O of n square is the time complexity. So that's why real time, most of the time, either we go with order of big O of n or n log n. So instead of n square, we prefer to we return the logic in such a way that that should be complete with a single loop, not the nested loop. But still, sometimes we have to use. So there we have to use the loop within the loop. One of the example patterns, you can print the patterns using nested loops, or you can use the, let's take example, you want to print the prime number list or Armstrong number list. So in that case also we can use the nested loops. So first I will take a prime number list. Okay, for example, I took a value called n value from the keyboard, and for that, till that value, I don't want to check whether the given value is prime or not. Till that value, how many primes are there? That when I need to print on the screen. Let's take example. If I given the input as a 10, the output should be 2, 3, 5, 7. Likewise, whatever the limit I given, till that limit, all the prime numbers should print on the console. So that is the logic what I want to implement now. Okay, for the example of nested loops. So here, first I want to take the limit. So to the what extent you want to read. Okay. So limit equal to int of input of enter value. Okay. Now you see, as we know already prime number logic, what it indicates, for that given value, no factor should be available, right? So for that I'm writing the logic. So, or I can say that what I will do first, okay, keep this as a comment. Okay. First we'll write the logic for prime number as we know already. So let's take n equal to, I'm writing 10. Okay. Now prime number logic, you know. So I'm taking count equal to initially 0. Okay. Now I'm taking for, sorry, I in range of, okay, 1 comma till the n. So that means n plus 1. Okay. I'm checking if n percentile I is equal to 0. I'm assuming you already covered the prime number. Okay, prime number means the number should not contain factors other than 1 and itself. That means if I'm dividing all the numbers with the given number till that number, example, if you give the input as 5, okay, if I'm dividing from 1 to 5, each number with each number, then it should not divide except 1 and that number. It means that only two numbers only should divide. Okay, example in 10, if you take 10, if I'm keep on dividing from 1 to 10, like 1, 2, 3, 4, 5, it has to divide only two numbers. But in this case, 10, 5 also can divide, 2 also can divide, 10 also can divide. That means 4 factors are coming. So that's not a prime number. The same logic I'm writing here. So count equal to count plus 1 I'm writing. Okay. It means that whenever the given value is divided by the iteration value, I'm incrementing the count. So just before I explained, if the count is only 2, because prime number has only always 2 factors, so that is 1 and itself. So if the count equal to 2, then that's a prime number. So I'm printing that value. Otherwise, I'm not printing any value. Okay. So let's case in this case, n equal to 10, it's not a prime, so that's why it's not printed. Let's take example, I'm taking n equal 11. Now I'm running the same program. Now you will get the 11. That means it's a prime number. Okay. But here, the given value is showing that whether it is a prime or not. But what is our expectation? Just before we talk, I want prime numbers till that 11 or till that 10. So that means the logic, whatever I written here for single prime number, that should be repeated for all the numbers what I given the limit. So that means inside loop is to check the whether given value is prime or not. But outside again I should write one more loop, that is for n in range of 1 comma limit plus 1. So this outer loop is to iterate the logic for all the values till the limit. So now this n is not required because already iterated, and the logic should execute for every value, so that keep in the loop. Okay. So now what happened, you see, outer loop is to iterate. Like example, if I'm giving the limit value 10, so our logic should repeat it for all the values from 1 to 10. So that's why I written the one loop for iterating 1 to given limit. And now once you the logic comes inside the loop, again I need to check that value is prime or not. So for that, this for loop will be executed. So now you see same logic. If I'm giving the 10, now instead of prime or not, it will give the all the prime numbers. See that 2, 3, 5, 7. If I'm taking the 20, okay. So now you see, you will get the output like 2, 3, 5, 7, 11, 13, 17. So likewise, if you want to run a block of code multiple times, we use the loop. But if you want to repeat that loop again for multiple times, then we will keep in another loop called nested loop. So now this is what we call technically nested loop, for loop within the for loop. So did you people understand that how the nested loop is working? So loop within the loop basically. And also will show you pattern that also will give you more clear picture on the nested loop basically. Any doubt as of now? Okay. Now we'll go with simple pattern. Okay. So it will give you also clear picture on the nested loop. Let's take example. I want to print 1 to 5 as a tabular format. Simple example I'm giving. For I in range of 1 comma 5 means you will be going for 6. And now for j in range of 1 comma 6. Now I'm printing each row in a same line. Okay. So for print, let's take example, I'm printing the I value, comma, to make it in the same line, I'm writing, sorry, to make it in the same line, I'm giving end is equal to empty braces. And after each row completed, I need to go to the second new line. So for that, print empty space. So now you see what will be the output. Just observe that. See that. If you observe that here clearly output. So how this output came? See, first, what is I value first? I value will be 1 first. So now it will go to the inside loop. For j in range, again within the loop, another loop will be there. So now what is the first line j value? It is again 1. So now print I. I used to print I only. So that's why you got the I value. But this range will repeat for this internal loop for 5 times. But 5 times you are printing I value only. So 5 times the I value, what it will be for the first time, it will be I 1 only. So that's why 5 times it's printing 1. Likewise, for every internal 5 times, the outer value we are printing 1, 2, 3, 4, 5. But if you want to sequence number, instead of I here, you can write the J. Now you will get the output, you see that 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3. Because J is keep on incrementing for every internal iteration. Okay, so means for outer I iteration here only just we use it for stepping to the new line, but J value we are printing to print in the sequence value. Okay, so likewise the outer loop will execute 5 times and inner loop is executing 5 times, totally 25 times. That's why you are getting total number of occurrence here 25. So each row 5 times, each column 5 times, totally 25 times. Now if you want to control this printing, you can write the logic. Example, I want to get only lower triangle. So in this case, you can write where j in range, instead of 6 here, write I plus 1. Now you will see the same output. You will get the lower triangle. See that 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, like that. So now you can play around this nested loop. You will get different types of patterns: upper triangle, lower triangle, pyramid, half pyramid, full pyramid. So these all structures will be generated based on the logic you tweak in this particular area. That is the basic idea of the what you call nested loop. But if you have the understanding of controlling how where that logic is changing or where the code is changing, so based on that you can write the logic. For example, if you want to print the ABC over here, assume that. So instead of 1 to 6 in that case, here let's consider what we can do 965. We can give the 65. Okay, and here instead of simply j means, as we know, it will print the 65 plus I. Oh, sorry, I is the, we start with j, right? 1 second. I plus 1 means not I plus 1. Here we should write 65 plus I plus 1. Yeah. Yeah, now you see 65, 65, 6 keep on coming. Now I want, instead of that, A, B, C are letters, right? So what I will do here, remove this first part. Yeah, now we got expected output. And now CHR you can use. It will typecast the given value into character. Okay. Now you see that AB, AB, ABC, ABCD, ABCD. Got it? So likewise, turn around. Like I don't want ABC, or don't want numbers. You want stars. Assume that. Generally, you will see the stars, right? In patterns, you can use the star to print the stars. So likewise, just you could tweak the logic. You'll get the different types of patterns based on your inputs. Okay. So this is how we will write the nested loops for our patterns logic, as well as for our list of data. If you want to print anywhere, we can use the nested loops. Okay. So this is the simple concept of nested loops. Any doubt as of now? Any doubt as of now? Okay, then fine. So please practice these concepts, and tomorrow we'll cover the some practical examples on dictionary. Okay, and maybe by using these loops also, and you can understand this topic. And next topic I will cover string functions. So generally we used different functions on the strings, like upper, lower conversion, and substring, replace, like that. We have almost 10 functions commonly we used. So that we will cover, and along with that, some other repeated functions also we use generally. So like example, random functions, like to generate the random value. So such inbuilt functions will cover in the next topic, so that the fundamentals will be completed. So we can start the very important topic called functions. So next topic will be functions, where we can understand how to write our own custom function, and how to execute that function we'll see. So based on that, we will continue the remaining topics. Like after functions, we have important topic like object oriented, how to create the class and object, and exception handling. These topics will cover in the upcoming days. Okay. So please feel free to ask any doubts if you have in the chat or here also. and we'll see in the next class with examples on dictionaries. Any examples as of now?
Same place. Hope we'll be achieving both of them in the next year. Let's move to the next thing, Capricorn.
Okay, I hope nobody have the doubt. Yeah, we can close the session for today.
So this PI we have two items. The